Hello friends, welcome to Jija Academy. Today we are starting the new chapter of calculus derivative. What is meant by derivative? Derivative is nothing but the how a function is changing at a point. That is the instantaneous rate of change. Now definition of derivative is equal to derivative of f of x is equal to limit h tends to 0 f of x plus h minus f of x upon s. That is the changing with time, this function. So this is the definition of differentiation. The process of finding the derivative of a function by using the above definition is called the differentiation from first principle or delta method. Now using this principle we are solving some problem. The first problem is to find the derivative of sin x at x is equal to 0. So here f of x is equal to sin x and f of x is equal to sin x. So we know that f dash of 0 is equal to limit h tends to 0 f of 0 plus h minus f of 0 divided by h is equal to limit h tends to 0 sin h minus sin 0. So we get here limit h tends to 0 sin h divided by h, and we know that limit h tends to 0 sin h upon h is equal to 1. So here answer is a 1. Moving to the next problem. Next problem is find the derivative of f of x is equal to k at x is equal to 0 and x is equal to 4. So here f dash of 0 is equal to limit h tends to 0 f of 0 plus h minus f of 0 divided by h. So is equal to f of x is equal to k. So f dash 0 is equal to k minus k upon h is equal to 0 upon h is equal to 0. Derivative at x is equal to 4. So it's equal to limit h tends to 0 f of 4 minus h minus f of 4 divided by h is equal to limit h tends to 0 k minus k upon h is equal to limit h tends to 0 0 upon h. So answer is a 0. Next problem is if f is a real value function defined by f of x is equal to x square plus 2x plus 3, then find derivative at 1 and 3. So f of x is equal to x square plus 2x plus 3. F of 1 is equal to 1 square plus 2 plus 3 is equal to 6. F of 3 is equal to 3 square plus 2 into 3 plus 3. So 3 square is equal to 9 plus 6 plus 3. So is 18. Now we are finding f derivative of 1 is equal to limit h tends to 0 f of 1 plus h minus f of 1 divided by h. So limit h tends to 0 f of that is a 1 plus h square plus 2 into 1 plus h plus 3 minus f of 1 is a 6 divided by h. So we get here limit h tends to 0 h square plus 4h plus 6 minus 6 divided by h. So limit h tends to 0, h square plus 4h upon h. So here we are taking limit h tends to 0, h common, h plus 4 divided by h. So limit h tends to 0, h plus 4 is equal to 4. So answer is a derivative at 1 is equal to 4. This is the answer. Now we are finding the derivative at 3 is equal to limit h tends to 0, f of 3 plus h minus f of 3 divided by h. So limit h tends to 0, 3 plus h square plus 2, 3 plus h plus 3 minus 3 square plus 2 into 3 plus 3 divided by h. So we get here limit h tends to 0, h square plus 6h here 6h plus 2, that is 8h plus 18 minus 18 divided by h. So we get here limit h tends to 0, h square plus 8h divided by h. So here we are taking h common, limit h tends to 0, h plus 8 divided by h. So limit h tends to 0, h plus 8. So we get answer is 8. So derivative at 3 is equal to 8. Now moving to the next problem, find the derivative of f of x is equal to x square minus 2 at x is equal to 10. So f of x is equal to x square minus 2. So 10 is equal to limit h tends to 0, f of 10 plus h minus f of 10 divided by h. So we get here limit h tends to 0, 10 plus h square minus 2 minus 10 square minus 2 divided by h is equal to limit h tends to 0, 20 plus h into h divided by h. So limit h tends to 0, 20 plus h. So we get here answer 20. So f of 10 is equal to 20. This is the answer. Moving to the next problem, find the derivative of f of x is equal to x at x is equal to 1. So here derivative of 1 is equal to limit h tends to 0, f of 1 plus h minus f of 1 divided by h. So limit h tends to 0, 1 plus h minus 1 upon h. So limit h tends to 0, h upon h. So limit h tends to 0, 1. So answer is 1. So this is the answer. Moving to the next problem, find the derivative of f of x is equal to 2x square plus 3x minus 5 at x is equal to minus 1. Also prove that derivative at 0 plus 3 into derivative at minus 1 is equal to 0. So here f of x is equal to 2x square plus 3x minus 5. So derivative at 0 is equal to limit h tends to 0 f of 0 plus h minus f of 0 upon h. So limit h tends to 0 f of h minus f of 0 divided by h. So we get here limit h tends to 0 2h square plus 3h minus 5 minus 2 into 0 square plus 3 into 0 minus 5 divided by h. So we get here limit h tends to 0 2h square plus 3h minus 5 plus 5 divided by h. So limit h tends to 0 2h square plus 3h upon h. So limit h tends to 0, h is common, so 2h plus 3 divided by h. So we apply limit, so answer is a 3. So f dash of 0, derivative of 0 is equal to 3. Now we are finding derivative at minus 1 is equal to limit h tends to 0 f of minus 1 plus h minus of f of minus 1 divided by h. So limit h tends to 0 to minus 1 plus h square plus 3 minus 1 plus h minus 5 minus 2 minus 1 square plus 3 into minus 1 minus 5 divided by h. So we get here limit h tends to 0 2h square minus h upon h. So limit h tends to 0 h 2h minus 1 divided by h. So answer is a minus 1 minus 3. So derivative at 0 plus 3 derivative of minus 1 is equal to, this is the equation 1 and this is the equation 2. So we get here 3 plus 3 into minus 1 is equal to 3 minus 3 is equal to 0. So derivative 0 into derivative at minus 1 is equal to 0. Hence proof. If you like the video, please like and subscribe the Jija Academy. Thank you.